Hi there, welcome to this video on Pythagoras Theorem. Just going to look at pre-exam questions. So, first of all, you need to understand the basics behind Pythagoras. So, if you have a right angle triangle, for any right angle triangle, you've got two shorter sides and they will be touching or forming the angle that makes the right angle, and then opposite the right angle is the slanted line, the hypotenuse, and that's always the longest length, and they're associated by this rule. So whatever this length is, if we were to square it, it would be the equivalent of the two shorter sides squared and then added together. So we'll look at a couple of examples that uses this. So again, this one it says that XYZ is a right angle triangle. XY is 3.2, XZ equals 1.7. Calculate the length of YZ. Give your answer correct to three significant figures. Now, notice here it says that the diagram is not drawn accurately. When the question says that, that simply means that you can't just measure it. So, this is a question where we've got two shorter sides and we're trying to find the longest length. So, if we labelled it A, B, C, what we're going to do is square the length A, that's the 1.7, and square the length 3.2, which is B, and that should give us this length squared. So let's put the numbers in. So 1.7 squared add 3.2 squared is equal to our hypotenuse squared. So when we do that, we do 1.7 squared and we add on 3.2 squared, we get 13.13. And that's our c squared, remember. So what we need to do finally to find c is square root both sides. So we end up square rooting 13.13. So c is equal to 13.8564064. But we must take note that the question says that we have to do it to three significant figures. So we're rounding it to three significant figures. So we're looking at 1, 2, 3 digits, so we're going to round it to this column here, which is the one decimal place. So it's going to be 13.9 because there's a 5 after the 8. So the final answer is 13.9. Must put our units, and there's that one done. So that's a question where you're just simply adding the two squares of the length together and then square rooting when you're finding the longest length. Now in this example, you can see that we're given the longest length and we're trying to find one of the shorter lengths. So you'll see a slightly different technique. So we're given this information here, which is on the diagram, and we've got to calculate the length of QR. This time it says give your answer correct to two decimal places. So if we label it A, B, and C, remember C is always the hypotenuse, the length opposite the right angle, and it's the longest length. So A squared plus B squared equals C squared. So A squared we don't know, that's what we're trying to find. B squared is 8 squared and C squared is 16 squared. So putting those numbers in, we've got A squared plus 64 equals 16 squared, which is 256. So A squared equals 256 subtract 64. So 256 subtract 64 is 192. So all we need to do now is square root both sides to get our final answer before we round it, which is 13.8564064. Obviously this must be less than that length, so if it comes out more then you've done something wrong, and we've got to round this to two decimal places. So that was a 5 there, so it's 13.86 because the third digit after the decimal point is a 6, so it's 13.86 centimeters to two decimal places. Okay, final example then. So this is a slightly more complicated example. So we've got a trapezium. ABCD is a trapezium. AD is parallel to BC. Angle A and angle B are both 90 degrees. And we're given these lengths. Work out the length of BC. Give your answer correct to three significant figures. Now, with this one, so what we're trying to find is this length here. Now, it's a Pythagoras question, but it's disguised in this diagram. So what you're trying to do is use Pythagoras in some way. Now, the way to do this is think about where could you draw lines that might help. If I drew that line there, then I would be able to use these to work out this length. But is that really going to help me find these? Not directly. We probably could use it in a long-winded way. So maybe if I drew a line from here to here, well, that doesn't, again, really seem to help because I haven't got this length to work out that length anyway, and then we don't have a right angle triangle, so it makes it more awkward to find. So the only place I can think of is if I do a line down here, will this help me? Well, we know this length is 2.1 and we know this length is 1.9. Now, this will be a right angle. So we've now formed a right angle triangle where we've got two of the lengths, and we could work out this using Pythagoras. So let's call this A, B and C. So A squared plus B squared is equal to C squared. So A squared we don't know, B squared is 1.9 squared, and C squared is 3.2 squared. So from here we've got A squared equals, if I take 1.9 squared from both sides, 3.2 squared minus 1.9 squared, which gives us A squared is 6.63. We then need to square root both sides, so the square root of 6.63 is 2.57487868, if I write down the full calculated display, and that's just this distance, so we've got to add on 2.1, so it's that distance plus 2.1. So if I add on 2.1 to that, then I get 4.67 and so on, and we're doing three significant figures, so we get 4.674878638 rounded to three significant figures, so we're rounding this one to 2 decimal places effectively, which is 4.67 centimeters. Okay, well, I hope that's helpful.